Welcome to this explainer. Today, we're diving straight into Dr. Heidrich Vicci's fascinating work, Artificial Intelligence, An Introduction to Humanity. We're going to strip away all those sci-fi myths and look at how artificial intelligence actually reflects our own human nature.
Think about a totally ordinary Tuesday morning. It's, say, 6:47 a.m. Your morning playlist is already queued up, your news feed is perfectly curated for you, the GPS quietly reroutes you around a traffic jam you didn't even know was there, and a fraud alert on your credit card was silently blocked while you slept. Now, none of this really feels like artificial intelligence, right? It just feels like Tuesday. Because AI didn't arrive in some dramatic sci-fi spaceship. It slipped quietly right into our daily routines, working behind the scenes long before we even knew what to call it.
And that brings us to the core theme for today. Dr. Vicci captures this perfectly when he says AI is not a threat to humanity, it is a mirror. And like all mirrors, what you see in it depends on who built the frame. To truly understand AI, you first have to understand the humans who built it, the people who trained it and encoded their own values into it. It's not an alien entity at all. It's a reflection of us.
So, let's jump right into Section 1, A Mirror to Humanity, the history of a very human dream. To really see how we got here, we've got to look back at one of humanity's oldest desires, the dream of creating an artificial mind. That has been centuries in the making. It actually starts way back in 1843, with Ada Lovelace writing the very first algorithm intended to be processed by a machine. Fast forward to 1950, and Alan Turing famously proposes the Turing test to see if machines could actually think. Then, at a pivotal 1956 Dartmouth workshop, the term artificial intelligence was officially born. After decades of wild optimism and crushing setbacks, 2012 hit us with a massive deep learning breakthrough called AlexNet that completely revolutionized how machines recognize patterns, setting the stage for 2022 when generative AI just exploded onto the global scene with ChatGPT. Moving right along to Section 2, How the Machine Learns, Demystifying the Mechanics. Okay, so we know the history. Let's pop the hood and see how these modern systems actually work. And what's super cool here is that you absolutely do not need a math degree to get this. Think about human learning for a second. If you're teaching a toddler to recognize a dog, you point out examples over and over until that conceptual pattern finally clicks in their brain. Machine learning is fundamentally different. It involves adjusting millions or literally billions of numerical weights across a neural network until the machine's outputs finally match the correct data. The machine isn't learning a rule. It's recognizing incredibly complex statistical patterns. Now, almost every AI application you use today relies on one of three basic learning paradigms. First, we have supervised learning. This acts kind of like a teacher and student, learning from clearly labeled data. Think of how your email figures out what's spam. Then there's unsupervised learning, where the algorithm hunts for hidden structures in totally chaotic, unlabeled data. This is like a streaming service grouping viewers who have similar tastes. And finally, reinforcement learning. This is where the machine learns entirely by trial, error, and a reward system. Speaking of reinforcement learning, back in 2016, an AI called AlphaGo played Lee Sedol. He was the world champion of the deeply complex board game Go. Now, AlphaGo had learned by playing millions of games against itself. But in Game 4, Sedol played a move so incredibly unexpected, his famous Move 78, that the AI assigned it a 1 in 10,000 probability and totally fumbled its response. Sedol later said he found the move specifically because, well, he was human. It's a great reminder that while reinforcement learning can master billions of data points, human creativity remains this distinct, irreplaceable spark.
But to truly grasp this technology, we have to be brutally honest about its limitations, because an AI generating a highly convincing essay still has zero actual comprehension of the subject. None. It cannot reason causally. It knows what goes together, but it has no idea why it goes together. It holds absolutely no inherent moral values. It only optimizes for the specific objective it's given. And importantly, most models cannot continuously learn from the real world once they are actually deployed.
Let's transition to Section 3, the psychology of trust, why we accept or resist.
You see, technical usefulness is really only half the battle. Just building a great tool doesn't guarantee humans will actually want to use it. Which brings up a fascinating question researchers have been studying for decades. Why do we fiercely resist new technology, even when it works perfectly? Well, the answer has almost nothing to do with technical literacy and everything to do with perceived risk and our deep-seated human need for control. Just look at the bizarre case of the automatic elevator.
Back in the 1890s, they worked perfectly fine. Yet for nearly 60 years, passengers flat out refused to ride them without a human operator physically pulling the lever. They just wanted a person in control. It actually wasn't until a massive 1945 labor strike in New York City stranded all those skyscrapers that building owners were forced to adapt and passengers finally learned to trust the machine. Our resistance to AI today is exactly like that elevator paradox. The barrier isn't technical at all, it's entirely psychological.
It really all boils down to your personal technology readiness index. If you're naturally innovative or optimistic, you're going to jump on board early. But if you score high on discomfort or insecurity, you're going to resist. And not because you don't understand the tech, it's because your own experiential model is warning you about unreliability or a loss of control. It's a completely rational calculation of trust.
Next up, Section 4, Working with AI Agents, the Changing Workforce. So, assuming we are willing to trust it, how is AI actually reshaping our daily work? Well, we are moving way beyond simple chat interfaces and entering the era of the AI agent. Unlike a standard chatbot that just answers a prompt and sits there waiting for your next instruction, an AI agent acts like a digital colleague. It's software that actively pursues a defined goal autonomously. It perceives its environment, plans out its steps, takes real actions using tools, and then evaluates its own progress.
It does all this through a continuous cycle called the agent loop. First, it perceives the current state of a task. Next, it plans its steps. Then it acts, actually using a tool to execute that plan. And finally, it reflects on whether it worked, revising its approach if needed. This seamless four-step loop is what allows an agent to draft emails, reconcile complex invoices, and review compliance policies while you are literally still asleep.
Now, the most empowering takeaway here is that AI brings task replacement, not job replacement. Let the machines handle the automated coordination, the routine status reporting, the predictive risk flagging. This elevates human professionals to focus on the uniquely human skills that algorithms absolutely cannot replicate. We're talking about ethical judgment, navigating complex workplace conflicts, exercising cultural intelligence, and building genuine human trust. Which brings us to our final part, Section 5, Bias, Ethics, and Governance, Polishing the Glass. We have to confront the flaws in our mirror here and figure out how we actually govern this immense power. Because the hard truth is, AI is not inherently prejudiced, but it will ruthlessly scale the biases embedded in our human-generated data. Take historical bias, for instance. We saw this when an AI penalized women's resumes simply because the historical hiring data it learned from was predominantly male. Then there's representation bias, like when facial recognition algorithms fail on dark-skinned faces because those specific groups were underrepresented in the training data. And there's measurement bias, where using flawed proxies, like looking at past healthcare costs to predict actual healthcare needs, ends up severely undervaluing the care required by minority patients.
This brings us face to face with a harsh mathematical reality known as the fairness impossibility theorem. Basically, this proves mathematically that you simply cannot satisfy every intuitive definition of algorithmic fairness at the exact same time when real-world baseline rates differ. Demanding that developers just make the algorithm fair forces them into making impossible moral and political trade-offs that math alone literally cannot solve. And then we have the deeply complex ethics of emotion. When we look at emotional AI, things like therapeutic companion robots for the elderly or mental health chatbots, we have to neutrally weigh the genuine relief these tools can provide against the profound ethical dilemma of using simulated empathy. As researchers point out, a bot showing a little empathy in a basic mobile wellness app might be totally acceptable, but deploying that exact same simulated empathy for vulnerable, grieving children or suicidal adults, that demands an entirely different standard of ethical scrutiny. Consequently, governments are taking vastly different approaches to AI regulation. It's creating this highly complex, multi-jurisdictional patchwork. Over in Europe, the EU has opted for the EU AI Act, which is a comprehensive, precautionary, risk-tiered approach. In the United States, it's currently a much more fragmented, market-driven mix of various state laws and federal preemption. Meanwhile, other global economies are relying on sector-specific rules that just target high-stakes areas, like finance. So, every global business has to strategically navigate this constantly shifting map. But perhaps the absolute biggest blind spot here is geographical. Get this, 75% of the world's population resides in the global south. Because of that, we are facing a massive risk of AI exclusion. If our frontier AI models are trained predominantly on high-income English-speaking data, which represents only a quarter of the world, those systems are going to fundamentally misunderstand or completely overlook the contexts, languages, and values of the vast majority of humanity.
So, as we wrap up this explainer today, I want to leave you with a critical question to ponder. Who should actually govern AI development? Should it be the tech companies building it, individual governments, maybe an international body, or even everyday users like you and me? Ultimately, who should hold the power to shape the frame of this mirror? And what are you willing to compromise to ensure that it reflects our absolute best human values? Thank you so much for exploring this fascinating topic with me today.